Hello, this is Nicholas from Silicon Chip Publications, and I'd just like to go through our January 2026 issue, which is going on sale around now at the end of December, to talk about what's inside the magazine. It's a 104-page magazine available in newsagents in Australia, New Zealand, and also by subscription just about anywhere. And on our cover here, we have DCC Base Station. DCC is Digital Command Control for Model Railways. So this can control trains in a model railway set. We have a remote speaker switch, which can switch numerous speakers between different amplifiers for sound systems installed in a home or a shop or something like that. Then we have some more articles mentioned here, which we'll get to. Let's have a look at the contents. So we have our 4 projects this month: the DCC Base Station, remote speaker switch, weatherproof touch switch, and the second part of our Earth radio, which picks up sounds from things like auroras and the solar wind and so on, and lightning. And then we have 4 major feature articles: acoustic imaging, part 3 of our power electronics series, how to use DCC, which accompanies this DCC Base Station project article, and an article on designing PCBs. This is second out of 3 in the series. Plus we have other columns: circuit notebook, service log, vintage radio. I'm not going to go through all of them. I'll touch on some of them. Let's turn to our first major article on acoustic imaging, which is about a relatively new technology that shows, see some pictures here, how it can actually show where sounds are coming from and analyze the frequencies, which can be used in various applications like finding electrical discharges that you can't see, finding gas leaks, detecting noisy vehicles, all sorts of different applications. So it's quite an interesting technology. It can also be used for tracking drones. So this is quite an extensive article that shows the technology and the history behind it. I said it's a new technology, but it has actually been around for a while. It just hasn't really developed fully until recently. So quite an interesting article there. And then we move on to power electronics. So this is a series that's been going for a little while now, and it will go for a while longer. I think there will be 6 or 7 or maybe 8 parts to it. And it's going through practical lessons on power electronics with some mathematics, but it's not really heavy mathematics. It's more about the general principles and how you can use them to design circuits. So this one is about DC-DC converters. So it starts out talking about transformers here, which is obviously a pretty important part of power electronics, and different kinds of transformers, how to analyze them. And then it moves on to talking about things like buck converters, forward converters, boost converters, so on, and how they work and how to analyze them and optimize them. So one of our more sort of academic series, but still very, very useful, I think. And we've tried to make it understandable for anybody with some mathematical skills, sort of high school level mathematics. Then we have this DCC Base Station, our first major project in the article. You can see here it fits in a little box. It has an LCD touchscreen and some various connectors. Here's the circuit. It's based on a Raspberry Pi Pico 2, driving a touchscreen and various chips to drive the railway tracks. There's a power supply as well, so it supplies power to the tracks, and it can send commands to multiple trains on those tracks to move forwards, backwards at different speeds, turn lights on and off, things like that, make sounds. Part of a series of articles. So the first one was a DCC decoder, which is the thing that goes inside the model trains on the track, and this talks to them and tells them what to do. And we'll have more parts. There'll be a DCC booster, reverse loop controller, and then also a remote controller that plugs into these sockets here, Con5 or Con6, that lets multiple people control trains on the same track at the same time with their own controls. So it's a complete system that you can build to upgrade if you have, for say, just a regular DC model railway system that has limited control, you can replace it with DCC by building these projects. Here's the back of the board, the front of the board. You can see there aren't a huge number of components, there are a few. Here's the overlay to help assemble it. We have the parts list here. We also have a kit that you can buy that comes with the board and most of the parts, pretty much everything except the case, really. That makes it easy. And then moving to the next article. Now we have this accompanying article that talks about DCC as well, because this shows the decoder from last month that works with the base station. They're all standard, so you don't have to use this decoder. You can use commercial decoders with our base station. You can use our decoders with commercial base stations and so on. But this talks about some of the principles about how you might want to connect it, why you need it, that sort of thing. how to configure it. And then the next article, remote speaker switch, I mentioned when I was talking about the cover. So the simplest application for this is if you have one stereo amplifier and two sets of speakers and you want to switch between them. Because it's remote, it has this control panel that goes on the wall here. It can be quite far away from the actual amplifier. So you don't have to run wires from the amplifier to the switch and then back to the speakers. You just put the control board where it's convenient, in between the amplifier and the speakers, and then you put the control panel where you want it, and then you just have to run a Cat5 or Cat6 cable between them. Runs off 12 volts DC, I believe. But you can also build multiple of these, and this shows here how you could build 9 to switch 6 pairs of speakers between 3 different amplifiers, so a total of 18 pairs of speakers. You can have just one amplifier with lots of speakers. You could have multiple amplifiers with just 2 pairs of speakers. You can configure it however you want, really. Again, here's the parts list. It's pretty straightforward because it's a fairly simple device. It uses relays to switch the speakers, and there's no microcontroller or anything like that. It's just simple DC control, so that's nice for people who like simple projects. And it's all through hole parts, so it's easy to assemble. Moving on to the next article, now we have a part 2 in our 3-part series on designing circuit boards. And this is sort of aimed at relative beginners or people who haven't designed boards before, but it also may have some application for people who have designed boards but maybe are not experts, because we give various hints about how to set up design rules to suit manufacturers, how to create libraries of parts that you can use, and so on. You can see here some suggestions about layout and labeling, and we're using Altium Designer as the example software, but this would apply to different packages, including KiCad, which is free. So, and he's talking about actually ordering the boards that you've designed. Now, in the next article, this is a simple one, weatherproof touch switch, which introduces a device that I think a lot of people won't be familiar with, which is a piezo switch. So there are no moving parts, and it's completely sealed. But you do need a little bit of, it's not just a simple switch, you need a little bit of control circuitry to handle it. So that's what we're talking about here, but otherwise a useful device. And then we have our Earth Radio part 2. So I talked about part 1 last month that had the circuit of this receiver, and it's not a normal radio where you pick up a station. It's picking up things like lightning strikes that could be thousands of kilometers away, or auroras, things like that, atmospheric electric phenomena, and it will convert it to sound so that you can hear it or record it. So here's our circuit board, and it shows how to mount the components on it. Here's the assembled board, one with the battery, how to drill holes in the case to suit it. And then this is important part, building the antenna, which is a timber frame with wire wrapped around it, many turns of wire. You need a big loop antenna to pick up these low frequencies. Here's a picture of the prototype antenna in use. Talks about building the antenna, testing it, etc., using it. We also have the serviceman's log, the 6 pages, basically stories that people have about how they fix things. And in some cases, they might actually have some useful hints for if you are trying to repair a similar device like a power supply here, what might go wrong, how to fix it, so on. But it's also just interesting to read about what people have done. And then here we have our vintage radio. Most, or pretty much every issue of Silicon Chip has a vintage radio or similar article in it. It might be vintage electronics, might be vintage test equipment, about older devices, radios, TVs, oscilloscopes, things like that, talking about how they were made, how they work, how to fix them if they're not working, which of course many of these devices being 60, 70, 80 years old have failed and need to be repaired or at least tested before they can be used. Talks about here how he insulated the mains wiring because it wasn't up to modern standards and so on, and also replaced some of the parts with modern parts because they'd failed or were just not working properly. In fact, often it's just the restoration of replacing what's broken. In this case, he actually substantially changed it because the valves that were used in the original radio are now hard to get, and he's basically changed them to slightly newer, more easily obtainable valves. But there was quite a bit of work involved in that. So it's interesting to read about how he did it, why he had to do certain things. Even came down to how to rotate the valves in rotate the sockets in the chassis so that the connections were direct, so that it wouldn't oscillate. And he shows some scope grabs here of the thing working, and then the final result. So it's quite interesting. Some of these old radios were quite nice looking. He's made it 2-tone. I think this was originally all one color. Personally, I think it looks nice with the 2 different colors. And that's pretty much it for this January issue. There are articles that I haven't talked about. I haven't mentioned Circuit Notebook. There are two circuits here that are shown, that one that ties into the DCC base station that measures the speed of model trains, and one about when you have a microcontroller that can access HTTP, but you need to use HTTPS, how you can get around that. Plus a few other bits and pieces. Anyway, I think an interesting issue, well worth reading. And as I said, it goes on sale late December and should be available by the time you're watching this video. Thank you very much. Have a great day.